So everybody who joins, the way we define family is whoever's living in your house. And so, and it's a self-managed kind of thing. You go in and you put in your data and pick out your password and your ID and your email address, and then I think we have up to like 5 or 6 for each family who can put in their own email addresses, etc. And then they'll get all of the newsletters and get onto the forum and stuff. Okay. So Joe, this is last time I saw you on the screen twice. You shut us down. So is that going to happen again? Turn your mic on.
I didn't mess up this time. I like to
Great.
model. I like to have a second computer
I see.
just so I can see what non-hosts see, especially if someone's sharing.
Okay.
I just messed up before because, well, I'm tired.
Okay. Well, I can't stress enough how really beneficial it is to join a club, because you're just hanging around with people who have years and years of experience and are always happy to share their information with somebody new coming along who shows a genuine interest. I have literally plagued people with my questions, and they're still my friends, 20 years later. Um, so you can just you you can save yourself a lot of like trying to figure things out and getting discouraged and quitting by joining a club. Um, I'm here to talk a little bit about the observing programs of the Astronomical League. Now, the Astronomical League is a club of clubs. So what it is, it's a kind of an umbrella organization for the amateur astronomy clubs of the United States. So there are about 300 clubs that are members of the Astronomical League. The Astronomical League, I'm not here to promote it. I think there's a lot about it that is a little out of date. Their website, for example, it looks a little pathetic, and their newsletters are clearly made by kind of doofusy old men. But there's a couple of things about the Astronomical League that are really useful to local clubs. And one of them is they offer clubs good insurance, which doesn't matter to you very much. But they also have these observing programs. And the observing programs come with awards. And they are absolutely worth doing because what they do is they help you learn the night sky, and they are a self-teaching tool. So here, I'm going to go to share screen. Host has disabled the participant screen sharing. Okay, and
Is it working now?
Yes, it appears to be working. Share screen. There we are. Share. Okay, here's the Astronomical League website, and you go to a section called Observe, and they have observing programs. Now let's see if I can find out where here we are. Observing programs listed alphabetically. They have a lot of them. And let me tell you what a real typical observing program would be like. And here's one that I think that whether or not you're kind of greedy for certificates and programs like I am, and you want to get all the awards and the certificates, or you just want to learn something about the sky, I would suggest that you learn the Messier objects. So it's a list of 110 objects, and they give you the list. Here it is, the Messier list. And you can also get it in PDF form. And you go out with your telescope and you observe these objects. You take notes, you put it together in a notebook, and then you turn it in. In our club, you actually turn it into our liaison with the Astronomical League, and he looks at it and makes sure that everything is okay, and then he contacts the Astronomical League and tells them that you've completed the program, and then you get your certificate and your pin. So just to kind of, here's a typical certificate. This is my lunar certificate. And then the pin looks like that. And I've got it on my hat. And I've got a hat full of pins. I sort of clank when I walk, because I also have pins from the Texas Star Party and the Oregon Star Party, as well as from the Astronomical League. And then the one that I'm most proud of is called the Master Observing Certificate, which means that I completed 10 observing programs. 5 of them were required, and 5 of them were of my choice. And okay, so why do this? I mean, why do something that's so kind of like cheesy and nerdy as earning these certificates and these pins? Well, number one, I'm always really kind of sad for somebody who goes out on the field and they're genuinely interested and they've got a telescope and they've learned how to use it. And then they go and look at like their favorite 6 objects in the sky. And then they turn around and say, well, now what do I do? What is there to see out here? And somebody sent me an email. Somebody from the public asked me if there was anything visually significant in the sky. I just wanted to slap him. Clearly this person hasn't done what I call catching fire. If you go out there and you see something and you go, oh, that is so beautiful. Let me see if I can see it in a bigger instrument, just get in a little closer, zoom in a little more. And then you go, oh, that's so gorgeous. Now, it doesn't look like NASA's image, it doesn't. It doesn't. But it's still beautiful. And you use your imagination to kind of fill in those colors and how it would look in a NASA image. So, but you can get kind of trapped in looking at the same few objects again and again and again. And there's no reason to spend a few $100s on a telescope or a few hundred hours making one just to go out and look at the same things again and again. So there's one reason to do these. And as I said, they're self-teaching. So there's a number of these programs that are really easy and can get you started. And they, in fact, on the website, they have their programs on a different page. They have them listed by whether they're novice programs or intermediate programs or advanced programs. So I would recommend, I always recommend starting with the Lunar Program, because you can observe the moon without a telescope at all. You can use binoculars. And that's what I did. I almost completed the entire program with a pair of binoculars. And it was only about the last 5 things on the list that by that time, I'd gotten myself a small scope and I was able to finish the program. So most programs ask you to look at 100 things. So like the double star program has a list of 100 double stars, or sometimes they'll have a list of like 120 and they'll tell you observe any 100 of this list that you want to. Okay. And when you look at the moon, you go, how can I look at 100 things on the moon? Doesn't take very long before you realize how many craters there are and how many ridges and mountain ranges and individual mountains. And there's ejecta, meaning that kind of stuff that scatters out on the face of the moon from impacts with meteors. Wonderful names on the moon. The International Astronomical Union has named every feature on the moon for a scientist, mostly classical scientists, including Chinese scientists and Arabic scientists and medieval scientists, Renaissance scientists. Dark side of the moon is the those are Russian names. So they're just fun to learn and they're beautiful to look at. And they teach you to take notes. And if you're going to go into any science field, you're going to have to be a good recorder of your observations. So that's what you do with these observing programs. Most of them have some kind of observation log they want you to keep. Here's one that came with the Open Cluster program. I don't like it, so I created my own observation log, which I like a lot better because I can put things in order that I tend to think of them. And then I have one circle here where I draw in where it is in the sky and how I found it. And then this one I use for what it looks like. So I can sketch at the eyepiece. If you tend to be artistic, sketching at the eyepiece is a wonderful skill to develop. You really kind of appreciate what you're looking at when you start to look at it really, really carefully. So that's another benefit of these observing programs is it teaches you to look at things, not just kind of check them off your list. What you do is you go in and you see the dark lanes, you see when you start to look at things like galaxies, you notice how far they stretch out. Sometimes there's companion galaxies nearby. Is it near some kind of distinguishing star or star pattern? If you're looking at a cluster, are there double stars within the cluster? Are there stars with some kind of color, like a carbon star or some golden stars, or particularly bright kind of blue-white stars that tell you those are very young stars? Um, there's all kinds of things that you want to look at and record. So it teaches you kind of some scientific observation skills. I remember I had a friend who was just a wonderful artist, just a terrific artist. And she said, I like art because it forces you to look at things, really look at things. So I took an art class, and the first thing I had to draw was a tennis shoe. I had to take a tennis shoe and put it on the table and draw it. And I remember just looking at that and taking my pencil and kind of going like this, and then trying to follow it down. Said, "Oh, now I know what she was talking about." So you develop observational skills. You develop note-taking skills. I am not good at drawing, and I've discovered that people who are good at drawing often write very sketchy notes, and people who are uh, not good at drawing, people who are good at drawing don't write good notes, and people who are not good at drawing tend to write really long notes, and that's what I do. Because one of my goals in doing these programs is if I want to come back and look at this sometime in the future, I want to verify that I've gotten here, right? Because there's thousands of things in the sky. I've probably seen a couple thousand objects in the sky, and they all have numbers that mean absolutely nothing to me. I know that there are people, I've met people in the club who can say, oh, this is NGC 2732, and it's so many millions of light years away, and it's such and such magnitude, and so many arc seconds across. And it's like this walking database, and even if I could remember that, I'm not sure it would mean very much to me. So my goal was always to learn the night sky. I was out there because I've told friends I want to know how to tell time by looking at the night sky. I want to look up and say, oh, it's about 10:30 on an early spring night, maybe March, right? Because I just want to know. And sometimes I'm out there and I know within about 45 minutes one of my favorite objects is going to be coming up. And so I kind of watch the east and seeing, okay, it's coming, it's coming. I know it's coming. Aha, there it is. There's my friend. Because the sky doesn't change. That's the one nice thing about it. It'll still be there the next time you go out. So one thing is you find that you learn parts of the sky, I found that sometimes I tend to avoid certain parts of the sky because the constellations there are small and they're dim, they're not very interesting. And but the observing programs will make me go into those parts of the sky that I don't know very well and make me pay attention to them and make me find some guide stars that I can use to move from here to here to here and then drop down a little bit and bingo, there's my object. Okay. It also, I think, is fun to just make really good use of your scope. You put some money into this scope, you put some time in the scope. It's heavy. You had to lug it into your car. You had to take it apart, put it in your car, go out there, put it back together again. And so it's an instrument, you know, it's like having a guitar or, any other tool that you use. And I just love it when I get in sync with my scope. And I just feel like the scope and I are working together really well. And I can find things and then I can look at it and I say, oh, I've got a little too much power on this. I need to back it off, because sometimes the really big objects, you don't want a lot of power on them. It's like putting too much zoom on something and you can't really see it. You need to back it off a little bit to see it a little better. But when I take notes, I tell people the least useful note you can write is wow with an exclamation point. And then you go back and look at this thing 2 years later, and that's your note. That's not going to help you very much. So when you write your notes like, how did you find this? Did you have to start from Regulus, which is like Alpha Leo, and then, work, and then you need to learn north, south, east, and west, which is really confusing. And, and then I think shape is a good thing to write down. If you're looking at a big thing like a galaxy or an open cluster, even a globular cluster, a planetary nebula, its shape, its color, its size, any distinguishing marks about it, anything that's particular to this. Does it have a gold star? Does it have a double star? Something like that. Okay. And then when you go and look at it again, that'll help you. I've done things where I said, oh, I've seen this before. And I went and I looked at my notes and I said, oh, no, I'm not on the right object. And I had to move my scope over just a little bit because I hadn't found it. So, Logan asked me, do you have a minimum recommended telescope size for spotting Messier objects? Well, telescopes are a little bit like cameras. You can get into photography really cheap. And then it isn't very long before you want a better camera and a better camera and a better camera and a better camera. And that's the same way with telescopes. You could get a really nice, useful telescope for anywhere from $200 to $400, somewhere in that range. And I would think, say, an when I started, 8-inch was actually, you kind of worked up to an 8-inch. And now people are saying, no, start with an 8-inch because telescopes, like all other technology, has gotten bigger and more powerful and actually rather cheaper over time. But I would say start with a Dobsonian telescope, a reflector that has a mirror. Okay, let me see if I can go find Amazon.com, Dobsonian. Here's a Dobsonian 8-inch telescope. Skywatcher Classic. Here we go. And let me share the screen. There you go. Share. Okay, there's a mirror down here at this end. And there's another secondary mirror up here. So the image comes down, the light comes down, hits this mirror, bounces back up, and then that light gets moved into, let's see if I can, moved out through your eyepiece. This is a relatively inexpensive scope. Let's see, this is what, $365. It's good size, doesn't weigh too much. Um, you can probably get it into your car. Let me see, how do I get? Oh, I just hate being this kind of doofusy old person here. All right. So I'd start with just a simple scope, just a simple, relatively cheap scope. The other thing you can do is borrow a telescope or two or three and see which one you like best. The Messier objects are the big, beautiful, golden nuggets of the sky. So I think you should learn them because they're kind of like your multiplication tables. You got to learn the Messiers. And uh, but of course, anything that you put more power on is going to look more beautiful, you know, so it does pay off to get a bigger telescope. But you don't want to get sucked into just buying bigger scopes because, you know, you're in a competition with somebody or I've seen people spend money they shouldn't have spent on scopes that they really aren't using. As you go up, you can take a kind of just an ordinary small beginner scope like that, and you can improve it by putting a better eyepiece on it. Voila, you've got a brand new telescope because you've put a better eyepiece on it. And the nice thing about that is that when you're ready to move up to a bigger, more expensive telescope, you take your eyepiece with you, you know, and move on up. But that eyepiece will stand you in good stead over time. Because you know, telescopes and binoculars are a little bit like glasses. You know, they don't, they just make things really clearer and dimmer things more clear, better over time. So that's about all I think I have to say about uh, the observing programs. Like I said, I like to self-teach. I really do. I used to go to work and I worked downtown. I was a legal secretary and I lived in the Hawthorne area and I walked across the Hawthorne Bridge and I'd walk across the bridge chanting the names of the mare on the face of the moon because I was trying to remember the mare Crisium, mare nubium, because I was like, oh, good, something new to memorize. Oh, good, something new to learn. So,
so if you all have any questions, you can either turn on your mic and ask them or put them in the chat and I will ask them for you. I'll start with one to get it rolling here. We do have, for these students, I have several telescopes they can borrow and they can come to the star parties we have. And I have about 30 pair of really crummy, but okay binoculars.
binoculars will work, yeah.
Are there any programs that they can start with that use?
Yeah, I saw that question, and there might be. Here, let's look at the list. The observing program. Here, are you? I haven't shared the screen yet, have I? Okay, here we go. Observe programs by equipment needed.
Oh, what do you know?
Okay, look at this. Naked eye, analema. So that one's kind of fun. You can use a camera for that. Astronomy before the telescope, constellation hunter, northern skies, Earth orbiting satellites, and meteors. So there's some programs you can do, naked eye, binocular, and then the telescope programs. And so what I would do is I would do the first 5 that are required for the Master Observing Award because those are kind of your basics. So for the Master Observer Award, you need to do, guess what? The Lunar Program. So you need to know the moon. The moon is a really nice place to start because you can usually find it. And, you know, you can observe it from your backyard and you can observe it almost every night. And you only need binoculars. And for some of it, you can do it naked eye. So it's a really good starting place. And then here's the binocular program, the binocular Messier, and then the full Messier, the double star. And then this one was the hardest one for me, was the Herschel 400. Most of the programs ask for 100. This one asked for 400. It took me a long time to finish that program. So those are kind of basic, and those will get you going. And then for the next five that are of your choice, you want to choose something a little more challenging. So I did globular clusters, I did the Caldwell list, I did galaxy groups and clusters. No, two in the view. I did two in the view, which is another kind of galaxy group and cluster one. I did urban skies. That one's challenging, more challenging than you would think. Because a lot of times I just couldn't see things in my backyard. The sky was just too washed out with light pollution. So I would go out with my club on a star party and I would locate something that I knew was on the list. And then I would come home and then I would know in my backyard what direction to look and how to find it. And so it was helpful to me to actually to have seen it in a better sky and come home and try to see it in a light polluted sky. That one's a little challenging just because the skies are so hard. So
So
now,
Margaret, that's another question that I have. Is
yeah,
I know that for me, it's pretty hard for me to get out of town. Uh,
yeah,
and I observe mostly in Gabriel Park because I have a very sweet small house with lots of trees, which I like, but it's bad
yeah,
for astronomy.
not
Uh,
a good place to observe.
and I guess my question is, of course, many of these you can't do in a light polluted sky.
Yeah,
Certainly the lunar you can do.
you could, yeah.
And I think the one that you were showing there that were naked eye, like asterisms and
Hmm.
constellations you could do. But I'm guessing that you usually go out of town to do observe.
I do. This is a real problem, and everybody who comes in new to the hobby always asks us, well, where can I go that's less than an hour away, and there's no lights whatsoever, and it's easy to get to, and nobody else will be there? And the answer is, oh, and it has a nice warm bathroom, but no white lights. And the answer is, well, when you find that, you tell us about it, because we're constantly dealing with this, and there's just really no way around it. The farther away you get away from light pollution, the better the sky's going to be. So in the state of Oregon, you got to get out there to Malheur Wildlife Refuge in order to find the really best skies that there are. But that's why as a club we set up events. We reserve Camp Hancock, and we have a star party there. We reserve Stub Stewart, reserve Rooster Rock state parks for our events. They're not the best, but they're better than probably trying to do it from Gabriel Park. And another thing about these awards is you need to be a member of the Astronomical League. So there's two ways you can do that. One of them is to join an astronomy club that is a member of the AL. So if you join Rose City Astronomers, then we take $5 of your annual dues and we send them to the AL, and you start to get a printed newsletter from them, and you can um, earn these awards. The other way is they do have them if they do know that there are people who live in places where there isn't a club. And so you can be what they call a member at large. And so you can just personally join the Astronomical League as an individual.
And
So,
since I'm really committed to getting more young people involved, Margaret, one of the things I've done, I'm not quite done yet, I'm 80% done. I want to run it past Rob and maybe you, is I've created a non-astronomical league beginners observing program.
uh-huh.
And that way you don't have to pay anyone, you don't have to belong to any club, and I would
Yeah.
just make it generally available. And it's just one beginning one, which is going to be, um, so far it's about 50% naked eye and about 50% binocular and not telescopic at
Yeah.
all. And then if people complete that,
Mm-hmm.
then they'll know, hey, they had a good time with this. Then they'll be motivated to join a club and to do the ones for the astronomical
Yeah.
league. So any of you, and I also wanted to say to, I even haven't told Rob this yet. I tell you, students, I am planning my summer, and I'm sorry. Whoops, you turned their microphone on. It looks like we're not going to get to have Pine Mountain Observatory summer
Yeah. Right.
for a variety of reasons involving COVID, but also involving me. Is that that's an enormous amount of work for me, as has been pandemic teaching.
Yeah.
So we're probably not going to do it this year. But the trade-off is my wife is going to visit her 101-year-old mother in Chicago for June. And so I would like to do lots, and I'm going to be just home alone in our house. And once I get my grades turned in on June 12th or whatever, I want to do a ton of observing, and I want to
Yeah.
with students, and I want to try out my new observing program.
Mm-hmm.
If you're going to be around in June, particularly the second half of June, I think June 10th is the new moon. So
It's a new moon.
get right on it, and then do the lunar part.
Yeah.
We can do that.
I'm
Students, any more questions? Or go ahead, Margaret.
Yeah, if you guys have an observing session, I'd love to be invited. I want to do some observing too. I want to try to get out to Logan Valley Star Party in June, and then out to Trout Lake Snow Park. Snow parks make really good places to observe in the summertime because there's nobody there. And that's been a traditional RCA Star Party. There's also White River Snow Park. And we have in the past just had informal events up there. The trouble with snow parks is that the outhouses are just really horrible. The one thing you find about observing, I always say, amateur astronomy is done at night, in the dark, in the cold, in the country. And it's usually done in the mountains or in the desert. And those places get awfully cold at night. Very, very cold at night. And if I've met more than one person who really likes the idea of, looking at the night sky, but they get out there and they don't like stumbling around in the dark, and there's sagebrush and the coyotes, they're yipping in the background. They got eaten by mosquitoes during the day. And there's a stinky outhouse over there at the end of the field that you have to try to find with a little red light. So they just find the reality of it is not appealing. I love it. I got out there and I said, this is great. I mean, I was just like literally felt like I had fallen in love with the night sky. And I still feel that way when I go out, you know.
Hey,
So the reality can be a little rough.
I have another question for you about finding objects. Now, the students you're talking to have all come of age since the smartphone, and they're very tech savvy. I guess two halves to this question. Just in general, what is your thoughts on beginners using a non-computerized traditional telescope? You already recommended a Dobsonian versus a computerized one. And the second half of the question is, if they get interested in the Astronomical League programs, are there rules about that?
Well, in terms of the first one, I recommend using what we call a push-to telescope, just a dome scope, because you can push it around and you learn the sky, you get your instrument working really well, you have your eyepiece and your finder working really well with each other, you look through your finder, you look through your eyepiece, bingo, it's there because you've got them working together. That teaches you the night sky. Now, a lot of amateur imagers, the night sky photographers, they're not particularly interested in learning the night sky. They want to get that image. And so they take a telescope, they tell it, I want to look at this, and it goes, zzz, it finds the object, and then they spend the rest of the night taking a picture of it. Nothing wrong with that. I never did it. I couldn't afford to get into it, and I just found way too many variables in the software and the equipment. It was just like, fussy and I just didn't want to do it. There is something called a go-to telescope. And supposedly what they do is, it's not really a telescope. The telescope's the telescope, hasn't changed. It's the tripod. The tripod has a little motor on it, has a little computer in there, little program. You push some buttons, you tell it you want to see M103, it goes zoom, it finds M103, and you look at it. In theory, those things are very hard to set up. And I've seen more than one person just give up on their telescope because they can't get it to work right. They're fussy, they're just tricksy beasts. And I would not think that that would be the best way to start. You want to start with something plain and simple. And you know, it's like a camera. You want to start with a nice simple camera. You don't want all of the fancy stuff on it because you don't know how to use it anyway. And all you've done is paid for a bunch of stuff that you're probably not going to use. I've had people come to me almost in tears because they spent money on this thing. They can't get it to work right. They feel stupid. They feel humiliated. And they just feel like they wasted a lot of time coming out here trying to get it to work. And they give up and they go home. But you know what? The telescope was still on the tripod. You could still look through the telescope. It's still a telescope. Just because the little motor and the tripod and the little computerized thing didn't work on the tripod doesn't mean you can't just push the scope around and find what you want to find. So I wouldn't get snared in that right away. Get yourself a nice, simple, dumb scope that's easy for you to lift, easy to pack into your the trunk of your car, easy to set up. Now, Rob disagrees with me about these go-to things.
Not much. Read what he said.
What did he say?
After 40 years learning the sky
and pushing my scope,
I built a go-to upgrade for it.
Upgrade for it. Yeah, I can
that's
see.
not the way to start out. And I agree with Rob too.
Yeah,
I think you should start learning the night sky. Also start with a mentor.
Yes. And that's why you join the club or you go out with some friends. Because I still feel I've been doing this for 23, 24 years and I still feel like a beginner. Because I still hang out with the people who were newbies when I was a newbie in the club at the same time. And we literally have sat down during the day and compared notes and said, well, how did you find this? And what does this mean? And, you know, we take our books and we look things up and we try to figure things out. And those are my buddies because they were beginners when I was a beginner and we didn't make each other feel stupid because we didn't know something. We just worked our way through it. It's a lot of fun. It's a ton of fun.
Well, we have about 5 more minutes and I have a lot more questions, but you know, I could talk to Margaret anytime. Okay. Any of you have any more questions? Anything?
Logan has lots of questions. Logan, did you have another one?
Logan's good that way.
Hey. All my questions have been answered. Thank you, Tom.
Okay. I do want to restate my answer. And I know for a lot of us, $12 a year for a youth or $30 a year for a family is not very much money. But I want you all to know that if you know any young person who wants to belong to the Rose City Astronomers, I have a friend who has supported my projects over the year who I know would sponsor any young person.
Yeah.
A member of RCA and he likes to remain anonymous. I've known him for 40 years and don't ever let money get in your way.
Okay.
Please no, just talk to me and I'll take care of it.
So Logan, you asked about age. I think that our student membership for $12 a year, if you can't find anybody else in your family, you could talk into doing this. And that is one thing about the club. You will find that we find it again and again and again. One person in the family is hooked on this hobby. Nobody else is. They all go, oh, this is really nice. It's getting cold. Let's go inside. Right? So if you can't get somebody else in your family to go, the $12 a year works up to the age of 18. And then after that, I think, but you know, we're flexible. You know, we're okay with membership.
I have one last question for you,
Okay.
Margaret. Your personal technique for finding new objects. How do you do that? Are you a star hopper or learning by rote, or any insights you have on learning to find objects that are harder to find?
Okay. Well, first of all, I use star atlases. And so I started again with very simple star atlases. And when I had found everything there was at that star atlas to have, I started with Night Watch by Terence Dickinson. At some point, I realized that I had seen all of these things, except, of course, the things around the South Pole and, you know, that I'm never going to see. Uh, then I graduated to a bigger, more complicated, more sophisticated star atlas, and I wore that one out and I bought another one. So I always start with maps, but maybe I do that because I'm a geographer. And in a sense, I see the sky out there as kind of like a big map. And so I like to read the sky the way I would read a map. And then I figure out what my first question is, what constellation is it in? Okay, because that anchors me in that part of the sky, right? And so I find it on the map. I find the constellation. Is the constellation coming up? Is it going down? On the page, it looks like it looked like this. In the sky, it's kind of at that angle. And so then I have to turn my map so it looks like that. So I'm not looking in the wrong direction. And then I use my Telrad and put it on the biggest, brightest star that I can find nearby. And then I just kind of like try to inch around until I find it. I also will refer to other people's descriptions of these objects. There are reference books where people have written up their notes and published them, and then I look at them and see if I think I found the right thing.
Yeah, that's always hard for me, is when I'm learning new objects and I'm by myself. How do I know I'm right?
Well, you don't, and that's why you go back again. A
You
lot
go
of
back again
times,
with somebody better than you, or
well,
more
that's
experienced,
right.
or at least who knows that object.
Yes, I've done that. I've asked somebody to confirm for me. I've asked somebody to see if they can find it. Um, you know, that's what's fun, going out there.
Well, Margaret, we want to really thank you for
Oh, you're
taking
welcome.
an hour of your time and
No
sharing
problem.
your 26 years of experience.
Thank
And I
you.
also want to thank you again for your many years of service to the Rose City Astronomers, but your
Yeah,
5+ years as president. That is
yeah, thank you.
endless work, and it serves so many people. But there's the trickle-down effect. I have learned so much from you and from Rob and from
Yeah,
Rose and everyone that I then share with the
yeah,
students. And I know that some of these students, like I know Katya, she's the oldest of 5 kids, or is it 6?
huh,
She shares with her Sims. She shares with her Sims. There's really a
yeah,
domino effect that's really great. So,
yeah,
bravo, thank you, Margaret.
yeah. Well, thank you. I really enjoyed being here. Thank you for inviting me. So yeah, if you guys ever go out sometime, send me an invitation. I'll see if I can, you know, work up some free time to go out there and meet you somewhere.
I will. Rob and I hope to have at least 1 or 2 more star parties before the end of the school year. But then, as I
Okay,
said,
great.
as soon as it's hard to be honest with me, and I think with the kids, it's hard for me to stay up late when school's in session.
Yeah. Oh, I get that.
But as soon as school's over on June 11th, and I hope to finish my grades on June 12th,
Yeah.
and I really want to dedicate the rest of
Yeah.
June to becoming a better observer and helping students become a better.
Yeah. Yeah. Okay. I
Thanks
hope you guys
again,
have
Margaret.
fun.
So long.
All right. Take care.
Thank you so much.
You're welcome.
Thank you.
Thank you.
Bye bye. You gonna shut it down, Joe?
Yeah.